What's going on, people of the internet? So today I am going to be building a quadcopter. So if you don't know what those are, that's these guys right here. Basically it's an FPV quadcopter, which means this little camera here broadcasts a radio frequency, or it broadcasts video over a radio frequency that you can look at with goggles on. So it's a hobby that I've been kind of getting into, and this guy here I built mostly from parts from China, so super cheap, which means their quality is also not the best, but I kind of wanted to see how I liked the sport and if I wanted to get into it or not. So I very much enjoy it, actually, and so I decided, now that I have a big boy job and other stuff, that I was going to try to build one the right way instead of, you know, $20 knockoff frame. Because basically this frame was not designed by whatever company in China I bought it from. It was designed by a company in Australia, and then the Chinese company basically ripped it off. And so for getting into the hobby, it was great. I mean, it works all right. It's actually kind of falling apart because I've crashed it so many times. But so I'm actually going to be building a new quad. So I got some better parts. So I'm going to kind of go over with the parts that I bought and what I'm going to do. And yeah, and then I'll get some shots of it getting built. And then, you know, I do already have some videos that I filmed a while ago of me flying this guy with a GoPro strapped onto him. I just 3D printed a little GoPro mount here, and this one's broken, but basically this mount bolted right here, and then the GoPro that I have just zip tied to this guy. And so last time I crashed, you know, you can see that this thing failed, but that's the beauty of a 3D printer, you just make more. But so yeah, let's get into the next quad that I'll be building. And if anybody's curious about how to build, or you know, what to buy or whatever, I will absolutely answer all of your questions to the best of my ability. What I found about quadcopters, FPV quadcopters, or drones in general, is that knowledge is kind of spread out in some different places, and there are some people who know like a whole lot, and it might be kind of intimidating to try to start and be like, how do I do this? So I want to try to be helpful if I can, because, you know, there were other people who helped me, and you know, if you find them, awesome, and if not, maybe you'll find me, and then I can either point you at them and you can absorb their knowledge or whatever. So sorry, I'm rambling. Let me get to the parts of the build. 1 second. All right, so let's get to the parts that I'm going to be using to build my next quadcopter. Like I said, that is my older quadcopter that I built a couple months ago. Kind of forget how long it's been. Maybe more than 6 months. I'll look on Instagram, because I posted an Instagram video when I finished it. Anyway, so the frame that I'll be using is the Skitzo Nova 5-inch frame. And so 5-inch means that like the diameter of this rotor is 5 inches, which means that if you look as this rotates by, it gets super duper close to hitting that. That means that this is a 5-inch quad. So if I could only fit 4-inch rotors on here, it would be a 4-incher. If I could only fit 3-inch rotors on there, it would be a 3-incher, etc. They get really small. There are these really cool ones called tiny whoops that basically you can fly around, like around this table. And those are great for flying indoors. This is more for outdoor. And this frame that I'm building is going to be what's called a freestyle frame. But we'll get into that later. So the flight controller that I bought is also a Skitzo Revolt flight controller with built-in OSD. So OSD is on-screen display. If you know quads, you know what that is. If you don't know quads, basically it's a little display that goes up on your goggles so that you can see stuff about your quad. You can have a lot of stuff on there, like direction, altitude, voltage, current consumption, etc. It's kind of up to you. What I will say is the more you put on there, the more confusing it gets. That's kind of relevant right now. But I bought this flight controller mostly because everything is plug and play, which isn't necessary, right? And definitely increase the cost of the flight controller. But this guy over here, I wish I'd taken it apart, but I didn't. You can see that there's not a lot plugged into the flight controller, this guy on top, but there's actually a bunch of wires that are soldered to it. So that's totally fine, except for it's kind of a pain. And so since I'm spending more money and not buying stuff, you know, from China or whatever, I figured I should try out the, you know, supposed to be more simple, quotes, flight controller to plug in. So then I got ESC, a 4-in-1 ESC. So ESC stands for Electronic Speed Controller. Basically, this guy is what gets a signal from the flight controller and distributes the power to the motors. So basically, when you look at ESCs, they will have an amp rating where they'll be rated to do that much constant amp and a burst amp. Those are all labeled. You can get them as cheap as the one that's on there is like $20, whereas the DA can go up from there. And then there's also another orientation of them where you put one on each like arm. So like the ESCs get put out on each arm. So the benefit of that is that if one goes bad, you only have to replace that one. Whereas if this thing fries, you'd have to replace the whole thing, i.e. you'd have to buy technically 4 ESCs, even though it's all in one. Personally, I like the 4-in-1, but obviously I've only built 1 and hopefully 2 quads here, so, you know, to each their own. The motors that I got are these Lumineer. They're 2650 kV motors, and the size of the motor is 2206. Right now, I wouldn't super worry about understanding the sizing. You can read really detailed articles about understanding what the kV stands for. Basically, it's a speed constant. So per volt, this number corresponds to how fast the rotor will spin per volt that's applied to the motor. That's kind of oversimplifying it, and you should read about it a little bit, but those are the motors I'm using. Yeah. I at least partially picked them because their color is dope, and I think it's going to match really well. But also because I was interested to try out 2650 kV motors, because these guys over here, let's see if you can see it on there. Let's put it down in there. They are, oh boo, it doesn't say on it. Oh yeah, right there. I don't know if you can read that. But right here it says this is a 2300 kV motor. So this motor will spin faster per volt that's applied to it, which means it'll have less torque per volt. Don't worry about it. Anyway, that's a motor. That's the motor I picked. The other 3 are up there. I just put this one here so you guys could see it. So this is my video transmitter. So basically, you know how I said that you wear goggles and that video that comes out of this camera right here is broadcast to my goggles. Well, this is the transmitter that I bought for this guy. Again, this is one of those things where the video transmitter that's on that guy, he's zip tied right up here, and he was like, oh, I want to say like $14. And the first one that I got was fried when I got it, and I had to buy a second one. And then buying stuff from China took forever. So this time I bought like the industry, one of the standards, like what I see a lot of professionals running. Just to see, you know, how much better really is it. There's other stuff involved, the power at which it broadcasts the signal at, etc. But we're not going to get into that today because it's already been 5 minutes of me explaining parts. This guy, this TBS Triumph, Team Black Sheep, this what TBS stands for. Anyway, this is my antenna. The reason I have that is I used to have 2 of these. This guy right here, that's basically what's in this box. And but I lost one of them when this guy crashed. It popped off. Basically, well, this connection is not super good, and so when the quad flies, it rattles loose, and so I flew for too long without checking it, and so when I landed, it just went poof and fell off. So I couldn't find it. It landed in a big field, and I walked around the field for like an hour, couldn't find it, looked like an idiot, finally gave up. So then I did buy a new camera as well. So this camera is the same company as the one that I have on there. I actually bought this camera used, and I've had some issues with it. I think the camera itself is fine. The previous owner of the camera looks like they glued it to try to keep it in place, but they glued it out of focus. So you can spin this little lens. Sorry, I'm ruining my light. But basically, if you can tell, I'm spinning the lens, and as I spin it, that adjusts the focus of the lens. And there's supposed to be a little lock ring up in there. Here, let me bring this up. There's supposed to be a lock ring in here. You can probably see it. It's right up next to the orange right now. That's supposed to hold it in place. But if you see that white stuff in there, that looks to be super glue. So the previous owner tried to super glue it to keep it in focus, but I don't understand how they goofed it up because it's totally not in focus at the place where that lock ring is glued. So that's been an ongoing thing for me, so I just decided to buy a new one. So that is a Runcam Owl, which was used generally for night flying, but I wanted to try it out, and it works good for day flying too when it's in focus. But this guy is a Runcam Split 2. So basically the Split can record video at 1080p at 60 frames per second. So I'm going to see how it goes to not have to carry the GoPro around, i.e. I won't have to print any more of these mounts and then, you know, snap them when I crash and flip upside down, because it will be housed inside of the frame down in there. So this is going to be my first try with this camera, so we'll see how it goes. So that's pretty much it. I also did buy these bullet connectors. So there's 2 of them right here. Basically the reason I did that is you will see right here on this quad that the motor wires, sorry, I only have 2 hands. See these motor wires here on the arm? They run into the ESC. You can see them come out of the electrical tape right there and run to that bottom board. So that bottom board is the ESC, the electronic speed controller, the same thing that I have sitting right here waiting to go on. So if a motor fries or goes bad or whatever, you have to cut that heat shrink off, desolder those wires, resolder new ones on, and go again. So you see I have 2 different colors of motors on here. That's not just because I wanted 2 different colors. That's because 2 of the motors already went bad once again, which is why I decided to buy more expensive motors the next time around, because those were super cheap. I forget what they were, but they were very affordable, which was great to figure out if I liked the hobby or not. But it's now been annoying that I've had to change 2 of them out. So yeah, I bought better motors, or supposedly better motors. I guess we'll find out. But to ease with my replacing, I will also be using these bullet connectors so that I can like cut this wire in half basically. And then just like that guy, halfway down the arm, I'll have the bullet connector, 1 on each side. So then if I ever need to swap it out, all I have to do is unplug the connectors and I can unbolt the motor and take it off. This will help the quad be less of a pain to take apart, because every time I take this guy apart, you may notice there's a zip tie up here. This zip tie is holding the video transmitter up, and you can see these wires are kind of just a mess under there. So I'm going to try really hard to clean it up and make it like a more professional looking build. So wow, that's 9 minutes of me just explaining this. Okay, so anyway, the first thing that I'm going to do is I'm going to drill holes in this piece of wood. Actually, this piece of wood is for my car ramps. So if you watched my videos about car stuff, you'll have seen that I have race ramps that I use to try to get my car on. But my car's too low to go on those. So these go in front of the race ramp, but I'm just going to drill some holes at the top. Basically, how you do these bullet connectors is you drill a hole that's big enough for it to set in the wood. Come here, little guy. So you drill a hole that's big enough for it to set in the wood, and then you can push it down just a little bit so the wood holds it in place. And then you can heat it up with your soldering iron over there, and then you can put some solder in there, and then when you heat it up and slide the wire into place, the wire just slides right in. So that's the plan for that, and putting little holes in it here isn't going to hurt me putting it on my car anytime soon. So I think that'll be fine. So I guess I'll probably try to get a video of me doing that. Hopefully it'll be dope. But yeah, I hope you guys enjoy the build, and yeah. Thanks, I guess. God, I hate looking at myself. Ugh. I'm sure everybody doesn't like looking at themselves in the mirror or hearing themselves talk, but oh, I hate it. All right, sorry. Kind of rolling. I'll get started. All right, so I'm going to drill one of the holes for these bullet connectors. Basically how I sized this is I literally took the bullet connector here, and I took my Ryobi drill set, and I just held it up to each one and said, hey, you look about this right size, that you'll drill a hole that's big enough that you will hold this guy in place, but not be so tight that, you know, or so loose that it just falls, or so tight that something else, so whatever. Probably just going to drill a few of them. I can always go deeper, but I don't want to go too deep right away, just in case that I get to the point where, you know, the thing's too far and I can't get the soldering iron on it. 1, 2, 3, 4. We'll do 6. 5 and 6. Okay. Making a mess. What I do best. Alright, and then we'll put this guy in there. So that looks like it's going to work. Oh, sorry. So I got 2 of them in here, even though I drilled 6 holes, and you can see they're in there. They're not too deep, and they're not too loose. So let me slide the rest of these here. Angle this down a little bit so you can see what's going on. Hopefully you saw any of that. Otherwise, I mean, I think it's pretty self-explanatory. It's just, oh, there's my computer being awesome. Alright, so 2 and 3, and then make sure I get these on the right side. 2 and 3. Okay, so I'll just say this. It seems kind of obvious to me, but I can see that maybe if I was in a super big hurry, I would forget or not look. But okay, so this bullet connector has 2 sides. The cylinder does. So obviously one of the sides needs to accept the other connector, right? So here's the one guy. If it'll focus, and so it's supposed to go in to this guy, right? So if you're ever going to do this, make sure that you get those right. Because if you go to the back side and you try to put it in there, it won't go in at all. This is really not going to turn out on video. But just, you know, make sure that when you do it, you get it right so that they'll squeeze together. I'm not going to crush it in there right now, but like, make sure that you check that. Because if you put the solder on the wrong side, I mean, the wire will go in, but you won't be able to get your bullet connector in. And that will be sad. And then you will be sad. Okay. Yeah. I'm going to open up some other stuff and do some other stuff before I get to soldering these. I just wanted to make sure this would work because otherwise I was going to have to do something else. All right.
Hey, what's going on, guys? As you may have noticed, this is not at the same time or place as the rest of the video that you were watching. So originally when I made this video, I was gonna like post it as like one big video, and when I got done with all the recording for this entire drone build, it was 4 hours long. And so some of that is gonna be sped up footage because like I did a building thing, and I'm just gonna speed that up, and you know, you can watch it if you want or not. But that's a really long video, so I'm actually gonna break it up into sections. So this is where I'm going to break the first section up. It's basically like the introduction. It kind of explains, you know, what you're going to see in the next several videos. So if you watched this and you thought, hey, that sounds interesting, please check out the rest of the build series. I'll probably be posting a lot of the build series on the same day because just watching an introduction isn't like a really interesting video. It just kind of is necessary to understand what's happening. So, thanks for checking it out, and I hope you enjoy the rest of the series.